Well, we stopped at how to connect batteries together. I've discussed inverter extensively. So by now, I believe that everybody will know standard, the best type of inverter that you should use. Maybe sachet inverter, am I right?
Yeah.
Or modified sine wave, pure sine wave, hybrid inverter, UPS, online inverter. Everybody should be able to differentiate all those inverters by now. Am I right or wrong?
Yes, sir.
You came late that day, shaking your head. You came late, just pray, say, may we do am again. And you can watch the class on YouTube. The class is on YouTube, so you can watch it. Maybe I've added you to the so check the link. I dropped some of the link so you can watch the class back on YouTube. So today I'll start on battery rack. Battery racks. I've done some videos on YouTube where you can see how to couple battery racks. The major reason why we have battery rack is number one, it elevates your battery from the ground. Most times when your battery is left on the ground, it deteriorates faster. That's why they normally tell you, if you want to leave the battery, put at least a wood underneath it. Am I right or wrong? Hope you get what I'm saying. How you guys doing? So we have now on battery rack, we now have battery rack based on the capacity of the battery. If it can accommodate 2 batteries, they say B2. If it can accommodate 4 batteries, they say B4. If it can accommodate 8 batteries, they say BA6. Then your battery rack, you can either have it in 3 formats. Number one, we have what we call your deep cycle battery. They are normally shorter. The battery rack for deep cycle batteries are normally shorter. You guys get what I'm saying? And cheaper. The next type, we have battery rack for your tubular battery. Tall tubular batteries are normally taller, as tall as this height. They are normally taller. Hi guys. What's happening? Everybody look dull today. It's good, Abby. Sometimes it's good to be so right. So we have that. Then we have battery rack that we use in hanging lithium battery. Battery rack of lithium battery is normal. It might just be one single iron like this. You nail it to the wall and you hang the battery. I said I will ask Alaja one thing the other time. Mike, Alaja, ṣé bí wọ́n ló bá mi kó microphone yẹn lọ sínú mọ́tò? Ẹ bá mi lọ mú wá. So next after that, we have what we call vertical racks. At least, was it your camp when someone was saying that one of the major challenges that he had is he can't identify between vertical and horizontal and roll and column. When we say vertical is going up like this, horizontal is spreading like this. If we say vertical racks, it means if they are using 4 batteries, all the 4 batteries will be on top of each other. And we normally use vertical rack in places where we want to save space. Like maybe you go and install solar from someone in Lekki now, where they need to save a lot of space. You might end up using vertical rack. I want to just put that battery under the the stairs. We use vertical rack. If it's 8 batteries, I've seen situations where all 8 batteries is a government project. They did it 8 one rack like straight up. Yes, on top of each other. They now put it in such a way that they tie the rack will not fall. Next, we have horizontal racks. Those are the ones that you normally see. All the 4 batteries with straight like this. Single. If it is 2 batteries, simple like this. So you have space. If you are installing a place like a Shogo now, you can put all your batteries straight down. Next after that, we now have some racks that combine both the vertical and horizontal. Like the 4 battery rack that we'll be using on the job that we'll be doing in Ado. Daddy can lead the job and take class. So on the horizontal, on the combined rack, you have both vertical and horizontal together. If it's 8 batteries, you might have 4 down, another 4 up. Hope you guys get what I'm saying. I pray we go to more sites where you see it. So your rack can be either made of your normal rod, the L brackets. The most common rack that we normally have nowadays are the L brackets. They will look like L like this. Just arrange this. There are some, the one I'm using in my house, for a few of you that have been to my house, you will notice that they are rods, not L brackets. In L brackets, you need, when you get to side, you need to adjust it so that the battery will sit on the L. But if it's normal rod, it should be like rod like this. It will be arranged on it. Are you guys get what I'm saying now? Then there are some people that use wooden rack. They will use wood to make rack. Like the job that I hired an architect or Kyle they did is wooden rack. But the major disadvantage of that wooden rack is sometimes when the battery, maybe you go and service the battery and the water, the distilled water or the electrolyte fall on the wood depreciates quicker than your normal rod. You know your normal rod, the moment you notice that it started getting rust, you do what? Just paint the rod. Hope you guys get what I'm saying, Sha? Yeah. So those are that on your battery rack. But for lithium battery, it will just be a single bar and you hang the battery on it. Some lithium batteries nowadays, especially 15 kilowatt and above, they have tires. So the moment you push it to where you want the battery to be, you use the stop-up tire to stop it. Are you guys listening?
Yes, sir.
Any question on battery rack? So in the absence of no question, I'll move to jumper cables. This is a good example of a jumper cable. This is 25 mm jumper cable. All of you are already familiar with gauge. You know that the higher the amps, the thicker the diameter of your cable. When did we start this class? We started this class
7:39, 8 minutes ago.
I won't back in here. 11:30.
8 minutes ago.
Yeah, 6 minutes ago.
6 minutes ago. So the class will be ending by 12:30.
I charge you.
Can I move on? On your jumper cable, we have what we call master jumper cables and slave jumper cables. Master jumper cable are the jumper cable that loops your inverter. They are the cables that loop your inverters to the battery. Even if you're having 16 batteries, if you're having 24 batteries, you have 2 that is connecting the positive and the negative from all the battery, from the closer battery head to the inverters. And your master jumper cable must be very, very thick. So if you are planning that 60 amps or 50 amps, if you are planning that is 60 amps that will be flowing from your inverter to your battery, you already know the thickness of the cable that it must be. Then we now have the slave jumper cables. The slave jumper cables are the cable that loop batteries together within the battery system. Slave. The master will connect your battery to your inverter. The slave are the one, like this short one now. Definitely it will be looping up. Definitely it will be looping up. So sometimes your slave jumper cable might not be as thick as master jumper cable because you are the amps that will be flowing through. Maybe it might be just 60 mm, it might be just 10 mm. Then on jumper cables, let me not hide this to you. We have this. We call it cable lock. Do you have cable lock in your bag? Even if you have, you know what to put it down. It's not what to get. So this is all called cable lock. Although some people they will cut wire, they make a hole within, you now tie it up. there actually there will be energy loss. It can, in Yoruba land, one must break carbon, meaning that there are rust on the tip. But when you use cable log like this, cable log make sure that all the connections are firm. Let me check the door.
This master cable is the one that will be charging the battery.
Not charging, is the cable that will loop your inverter to the battery.
And is it the one that is charged, or
It's charging and discharging at the same time now.
So the slave, they look the battery together.
Yes, yes. Depending, you have cable gauge. Is your cable is the volume of the amps that will flow that will determine the thickness of your cable. So, any other question?
so this master cable now serve as an output from the inverter.
It's not output, it's also an input now. As it's charging the inverter, it can also, when the inverter needs to consume energy from the battery. Now, so it's both ways. And it's the one that it's the one that will be carrying the highest volume of current. Mostly is the thickest part, is the thickest one out of all the cables. Can I move on now? So we have the cable log like this. Most times, if it's not ready-made, sometimes you can buy ready-made jumper cables. When you go to where you want to buy, maybe Alaba International Market, Arena in Oshodi, or you go to Computer Village, you can decide to say, I want to buy 60 jumper cable that are ready-made like this. But if it's not ready-made, after you have used your plier to make it firm, I pray that it sees one. Or the DC cable wey remain yesterday, abi my DC cable no remain. So go bring am, let me use am. This, we don already log this. So this is how a cable log look like. Okay. So this is how it looks like. And the thickness of, okay, you can, I know this phone is safe. This is all that remains.
Yes.
So the thickness of your cable will determine the size of the cable log. We have the 16 we have the 25 we have the 10 we have the 6 cable log. And note, it's even better that your cable log is bigger. Let me say I'm using 16 cable and I get 25 cable log. I can easily compress it to meet up with it. Then I'm getting a 10 cable log for a 16 cable. Then another thing we have, you now use maybe your black tape or your masking tape to tape the cable log so that the wires will not flow around. Next, after that, we now have what we call the battery gel or battery grease. Before you connect your battery terminal, we normally use the grease. So this is an example of cable log. This one is 10 cable log. So if I want to use this now, let me bring blade and plier. I'll not. Let me do it here. So pending the time you bring this, we have what we call the battery gel. We normally put, when you buy a new battery, you see that gel there. It's not cream. You put it on the terminal of the battery so that there will be easy flow. It increases conductivity with this cable log. Then it protects that battery head from being carbonized. Sometimes that battery, you see it generating some foam powder. When you put gel there, it protects it over time. Although over time that gel will fade away with time, but at least it increases the conductivity and it protects it. I want to do the I'm trying to make it. So let me assume that I want to use this to now. Plier. and I will use my plier to hold it. There are even some charge controllers, especially the 120 amp. There are some charge controller that is cable lock that you use to tighten it up. So then you now, after doing it like this, now you put your black tape. After pressing it, using it to make it fast, now use your black tape to tape it. That's how to make cable lock. Assuming you don't buy red made one like this. You know, this one already have its cable lock and tape. So you can use it. And sometimes when you run your solar panel coming to your charge controller, or from your charge controller coming to your battery head, you have your cable lock like this. To wire straight. Yeah. No, no, there is no disadvantage. This one just make your job neater. It look more beautiful. That's all. So then, how do we now connect our battery head? Let me assume that this is my battery head. That's the mistake that they made in that pastor side. And you know let me say your cable lock is on this side to connect. Maybe this one is connected to another battery. I want to connect your panels and this other cable lock. We don't put the two together on the same place like this and tie it up. Each of them, this must connect at the other terminal like this. And the two of them must have direct connection to the battery head. Hope you get what I'm saying.
Yes.
So this should be connected directly to the battery, and the other one should be also connected directly. It's not that you join the two together like this, or join the two together, assuming that this battery head on the other side like this. It was directly connected like this to it, so that as the panel is charging the battery, this also can bring out energy. Hope you guys get what I'm saying. Hope you guys get what I'm saying. I assume that this is the battery head. This one, assuming I'm connecting this like this, maybe this one is going to my inverter. It must touch the battery directly, and the other one must also touch the other side directly. It's not joining. Although some people they will peel the wire like this, they will make they will tie it up. Maybe because they don't get cable lock. And another thing, there are some installation you see that they will give you what we call washer. At least everybody knows what the washer is. You don't put washer between the battery head and your cable lock. It's not that you now put the washer in the middle like this. Your battery head must have direct contact with your cable lock. The washer will now be at the back here. Let me look for one washer, Gary. Let me bring one washer. The washer should be at the back, not in between. Yeah. So let me assume that this is the washer now. The washer is like this. It must be at the back, and your screw now. Let me now say, we now go like this. And tighten it up like this. It's not that the washer will now be between your cable lock and your battery head. I assume that this thing is like a battery head, so that you can have an easy flow of electric. This is not something that I'm telling you. The day it go fuck you up. The last job one of the jobs that we did of recent, the guy just connected. We shall notice that the battery was reading 14.5 abi? It was reading around 17 volts. How battery go dey read 17 volts? Maybe you are there. That place where dog was barking. That pastor that we did solar. Yeah.
Due to, from Faraday's law of electricity, it says that any conductor can conduct.
Yeah.
Now, let me link it to this cable breaking that we did. Now, it is the amount of cable, the cross-sectional area of that cable that determines how. If since the two now are conductors now, so what is the effect if I now put the washer directly to the battery head before putting the cable.
Let me ask you one question.
The two will still conduct.
Let me ask one question. I will use a real life scenario. Do you know that sometimes when there is carbon on your car battery, the light will not be enough to start the car? Haven't you noticed it? They will tell you to go and use maybe hot water or coke to wash the battery head so that you can have enough contact area. It's not that there's no contact. So a place where maybe 40 amp should be flowing, because there is a gap between, you now have up to 40 amp. A battery that now should last like maybe 6 hours, you will not be hearing, they will be telling you that it's using 4 hours, because you need maximum contact points between your battery and the battery edge and your cable log. Even there are sometimes you see some people when they put it between it, over time, especially if it's a battery that is receiving like 40 amps, 30 amps, you will notice that this thing will have become very thin. Sometimes it will even be very difficult to remove it from the battery edge. So you need your maximum contact point. Like that job that we did, the guy did not tie the head very well. It was even you that did not tie it very well that day. So instead of giving up the readings, instead of the inverter to pick up from the battery, and should be within the range of maybe 10.8 to 14.5 volts, it was picking up from the panel, which is around 17 volts. So the inverter was complaining. Thank God you were there. That the inverter will start and trip up. Initially, we thought even the inverter was bad, until when I now check the contacts. Hope you can hear what I'm saying, because your inverter also have tolerance. Most inverter is, the moment it's more than 15 volts, your inverter will trip up. You will be seeing it as abnormal energy, except maybe you are using lithium batteries. Are you guys getting what I'm saying? What I'm saying now? And sometimes now, I've seen a job like that. Joseph of blessed memory, now one of my trainees, after connecting the battery at that guy's house at Ode, we just noticed that the inverter will just start and go off. That my guy now is my trainee. I also learned from him. Now, guy, go and buy coke. Use coke to wash all the head of the batteries. You now use coke to wash all the head of those batteries. Connect it back. The battery start up. You know what the coke did? You know, coke is very corrosive. It's removed all the impurities on the battery head. The guy was just looking at us like, the guy himself have tried to start up the inverter. No, it's just because there are many carbon on the edge of the inverter. That's why it's not working. Why am I saying all this? If there is partial contact, not full contact, your battery might start misbehaving. Just imagine you have maybe a 96 VDC and one of them is losing contact. Your customer will think the battery that you sold or that you install or that is on ground is not working fine, whereas it's partial contact that is making it not to function very well. And the partial contact doesn't only limit to charging. Even in discharge, your battery that should use like 8 hours, 10 hours, 16 hours, as the case may be, they will just tell you that after 4 hours, the battery trip off because it's not having enough current. It's not able to tap up enough current. And not only charging, it also, as not only discharging, it may also affect the charging as well. The current will be flowing, but enough current will not be reaching the battery. Next, how do I know that the cable that I use is wrong? Apart from your having that's why I gave you guys assignment so that you can know the standard cable gauge. How do you know that the moment you are touching the cable and you notice that the cable is eating up, your cable gauge is wrong. Maybe a place where you should use 16 mm, you now put 10 mm cable there. The moment you are touching it like this, and the cable is eating up, you are noticing that the cable is hot. Your cable at any point in time should be what? Cold. Normal temperature. The moment you start noticing that this is hot, the cable gauge is wrong, go and change the cable. There was a job like that one person did before. It was my friend that called me to correct the installation. By the time we get there, because the thing is getting hot, the two have met together. Thank God that the inverter has circuit breaker. So the moment the two wire touch, the inverter break. So the installation is not up to 6 months. So the man now called us. By the time I got to that site, I said, by the time I checked the cable has met. I said, you should even be thanking God. Because in some instances, the whole place it burst into flame. There was a video I posted on the general WhatsApp group some time ago. It was ordinary cable that burned down around 17.5 kilowatts battery, lithium battery. That's around 9 million. And 3 inverters. Each of them can be less than 1 million. So just run cable, maybe less than 10,000 naira difference, burn down a facility of around 15 million naira. I will try to see if I can see that video again. I will repost it again on our general WhatsApp. I don't want to post it online because someone might have created. It's not my job that it happens, but I saw it on the job. And thank God that they have CCTV in that facility. It was the wire like this. That the moment the two wire comes up, spark and flame, and everything busted into flame. So this your gauge of your cable is very, very, very important. It's one of the places, burst out and the marine board got put. I say, as long as your cable is okay, you are using the right cable gauge, your contacts, either your cable log or connecting it to the panel or the child controller is well farmed, the terminal points are well farmed, there's no way fire will come out. Well, maybe your village people, your village people might throw fire there. And it's normally advisable that, I normally advise it, that they put one fire extinguisher where the inverter and solar system is. I'm actually taking my time, but I've noticed like 3 videos like that. That is the cable that burnt down the whole facility. Because, it might not eat up, but the moment it's now charging, maybe they just bring in electricity and it's sending like 50 amps. Just imagine 50 amps flowing through a cable. And it's like you are. Let me put it. What is a better way that I can put it? It's like you have a small pump, thin pump. You are now putting a lot of pressure there. The pump might burst. Any question for? That is a very good question. The disadvantage is that it will cost you more money in terms of costs in naira and kobo. But it's even better that it's better that the cable is bigger. But you might not be the only one bidding for the project. You might not be the only one bidding for the project. So when they now decide that your cost is extremely high, and there was some installation I did of recent. I was telling them we are having 10 panels here. Let's use MPPT. The man is an engineer, so he said, I don't need MPPT. Put your PWM there. You get what I'm saying now? So because of the consideration, you might not be the only one bidding. Use the standard. The one you discover is within the range. Use the standard one. But if they can say, can't I use bigger cable? Or maybe they have it in mind that in the future. There are some people like the job we went to do yesterday. The man started from 1 battery, 2 panels. Later increased to what? 4 panels. Later I said, I want my inverter. I want it to be powering my pumping machine. We remove the 1.5 kVA that we put there. We put 2.5 there. We put 2 batteries. If it's someone that has the mind of upgrading, you can put a larger cable gauge so that by the time they are upgrading, they don't need to start changing those cables again. I have someone like that. After he started from 1 battery, later to 2 batteries, later to 4 batteries, currently 8 batteries. And you know that the more those batteries, the inverter, the more the current that will flow. Although, like Felicity now, there is a setting on Felicity inverter where you can increase the charging amps. You can put it on 20 amps, you can put it on 30 amps. There are some Felicity that you can even adjust it up to maybe 53 amps. And the larger the amps that is flowing to charge your inverter, the more what? The current that flows. the bigger the size of your cable. Yeah, another
So
question.
let's say there's no charge controller. How do we calculate the right millimeter wire to use?
I have told you now, your wattage divided by the voltage will give you the amps. So if I'm on 3.5 kilowatts inverter, averagely, let's assume that all other factors remain constant and it's on 220, I will say 3,000 watts, 3,000 divided by 220 volts. Yeah, how many amp will it bring out? Yeah, use your calculator now. I miss David. That guy is a mathematical genius. Often like this, anything you ask, you just be doing like this. You know, he's now a staff at Redeemer University. 18.6 is 13. It means if you have an inverter of that size, the average charging will be around 13.6 amps. That will be flowing from the inverter through to the battery, through the cable to the battery. Although there are some inverters, as I said earlier, that's why the inverter is 13. They have an allowance there where you can adjust it so that your battery charge faster. And just it maybe 20 amps. You know, if you are putting 20 amps on 220 volt battery, assuming all other factors remain constant, that's an average. It will take like 10 hours to charge up the battery. Assuming the battery is zero, although most battery can be zero, you have energy left. So if you increase the amps, the battery charge faster. I explained those. Okay, it came late. I was explaining it when I was explaining rectifiers, DC rectifiers there. We have questions again on.
So, sir, if I use the batteries, are we still going to use that same calculation?
Yes, now that calculation is meant for your master jumper cable that is connecting your inverter to your battery. You know, the slave one might not be up to that. Hope you get what I'm saying now. Let me say I have 10. Let me give you another calculation now. 7.5 kilowatts divided by 220 volts. Check how many amps.
7.5.
Over 220. I'm waiting.
0.0.
0.0.
No. It can't be zero. Sorry. It should be 7,500. When I say 7.5 kilowatts, you multiply by 1,000 now. How do they do like Ote?
No,
Ah.
my mind.
Because I never 34.1.
34.1 amps. So you now go to that assignment I gave you. 34 amps. What's the cable gauge that works from 34? Do you know how to understand how to calculate it? 6 mm. Have you checked it? Because someone makes mistake.
Around 25 to 30. That's
6 mm is using 40 amps.
Mm-hmm.
6 mm is using 40 amps.
Let's say 10 mm.
No. Let's use the standard one that is there. 40 amps is what? 6 mm. So it's still run on 6 mm. And you need to note, especially in the environment we are, don't let me say in Nigeria. Most times when they say the cable is 6 mm, by the time you put the gauge, it might be like 5.2 or 5. And you know, there was a day I and one of my clients, we went to where we want to buy cable. They were now telling him that this cable then was 15,000. This other cable is 13,000. I was now looking at it like, why is it different? If you now carry your micro gauge and check it, it might be the thickness of the wire. It might be the quality of the component of the wire. Are you guys getting what I'm saying? So you need to be sure of your gauge. That's why sometimes I normally advise, if you are not sure of the quality of the wire, if you should use maybe 6 mm and you have the capacity to get 8 mm in that environment, the 6 mm might not be actually 6 mm. You might go for 8 mm. You assume that all things being equal, because the wire might not be the 6 mm, so that the wire don't burn off later. Because I've had experience. I gave that guy money to go and buy, don't let me say the name of the company, the wire. He now bought another wire, use it to run it. Say, a bit alarm. That wire, thank God that house is POP. Assuming it's another thing, the wire just burned to a certain extent. So the person just called me that the thing cut off. When we got there, and I called. I'm talking about something that happened around 2019, and I called. Thank God he's not yet through with the service. Say, is this the wire I said you should buy? And I told him, this is your punishment. Now, from your allowance, I will remove the wire to buy the money to buy the normal wire that we should use there. And there might be a surge, maybe an high voltage coming in brown. As long as your wire, your cable gauge is right, it's not the wire that will get burnt to. You are using a correct and original wire, and you are using the correct gauge. Because fire is one of the major challenges that we face in solar when you use the wrong specification. Any question for me on cable gauge again? It will affect a little bit, but you know when we are talking of jumper cables now. We are not talking of standard DC cable. When we get to here, we ask that question. We are talking of jumper, master jumper cable and slave jumper cable. And when you are talking of jumper cable, they are short. It's not long. You know, as the distance is increasing, the resistivity of your cable also increases. So that question should be asked if you get to DC cable. We are talking of just master jumper cable and slave jumper cable, as the case may be here. So any other question on jumper cable? So in the absence of no question, let me now move to another cable. You know, we have assumed that we have connected our panel. We have what we call AC cable. AC cable. Alternating current cable. That is the cable that carries your 220 volts, maybe from your power holding company. You know, there was a day I was reading checking the tweet of Ikeja, maybe Ikeja Electricity Distribution Company or Lagos Electricity Distribution Company. They said when they bring light, that people should not be shouting up NEPA again, because there's nothing like NEPA again. One guy that put it on that tweet that they should be shouting IJK. Before they shout it finish, they have already removed their light. That was just a joke, sha. You know, on your AC cable, you have your 220 volts. Are you guys listening now? In your AC cables, it has higher voltage, lesser current. Are you getting what I'm saying? If you are on DC line and it's 3,000 watts, 3,000 divided by 48 volts. But in AC, it's 3,000 divided by 220. Are you hearing what I'm saying now? So when you're on AC, the gauge, your cable will be smaller in size compared with DC. Are you with me now? Under that, we have 1 mm cable. We have 1.5 mm. We have 2.5 mm. We have 4 mm. We have 6 mm. We have 8 mm. We have 10 mm. We have 60 mm. That's how cable goes. Am I right or wrong? Although there is a rough estimate I normally tell my guys, if you don't have your cable gauge around and you want to be on the little safer side, although that's not the standard ratio. If you want to buy 2.5 mm cable, 2.5 mm inverter, just go for 2.5 mm cable. If you are using 3.5 kVA inverter, just go for 4 mm cable. If you are using 5 kVA inverter, go for 6 mm cable. But there is still a standard calculation that I gave you earlier. Do what? Say 3,000 watts or 3 kVA divided by 220 and give you your arms, and from that arms you go and check your cable gauge. Hope you guys get what I'm saying now. Maybe they just call you to that job and say, you have already gotten cable. And don't try. I normally tell my students, don't try and manage cable. Don't try and manage cable. If you are trying to manage it, it might be there where the fire will come from as a result of it. Tó bá gbé kíkọ́ yẹn sí báyìí. Do you guys get what I'm saying? So now you have your AC line. AC means you are connecting your 220 volts to what I'm trying to say is that maybe it's charging your inverter or is giving it what's out. You have the input and output. Input means the one that will charge the inverter, and output means the one that will supply electricity out. And sometimes I normally advise the thickness of your charging sometimes to be on the cellular side should be bigger than the one that will come out. So if I'm using 4 mm to charge my inverter, it might be 2.5 mm that will bring out the energy. If it's a 2.5 kVA inverter. Are you guys getting what I'm saying? Although I've seen some of my guys that will say, no, maybe that 2.5 mm will go. The client might decide tomorrow to put maybe one AC on the system. As the inverter can carry the AC, it will still be working, but that wire will be eating up. It might be a pumping machine. So you must factor all those things inside. Hope you get what I'm saying now. So that's for the AC side. And in your AC side, you need the wire that will charge your inverter. And you need the wire that will bring out energy from your inverter. We'll still do the drawing later. Another wire that we have what we call the DC wires. I'm not coming to the DC wire yet. On your AC line now, you have what we call AC breakers. Your AC breaker will work on maybe from 110 volts to 240 or 250 volts, or some cases 300 volts, from 110 to 300. That's AC. And we call AC, we call it VAC. VAC means voltage alternating current. So your VAC, if you are in places like United States, they run on 110. If you are in India, Nigeria, you run on 220, 240. But one funny thing is that except your house is very close to the transformer, the more the distance your house from the transformer, what will happen? The lesser the voltage that you receive. You notice that the job that we did at GRA, we see 240 volts because that place is as close as possible to the transformer. Any question? We are going deep now. So questions have started reducing. So by the time you go to site, you understand. Do you enter the house and see the way the inverter is set up? So those tiny wires that come from the back of the inverters, they are the AC. The one like this is the DC. The one coming from the battery to the inverter that is as thick as this is the jumper cable. For two of you, it's 3 of you now that went to the site now. This one is already organ. So 2 of you, you start familiarizing yourself with it. You went for CDS yesterday now. So
I want to ask about
the moment is 12:30.
You said that it is the wattage all over the voltage now that will give us amps.
Yes.
Now, how am I going to? Is it the total battery that will calculate for the voltage, or
you are mixing it up? Battery is VDC, and your VDC might be 48 volts. So if I want to check the amps, I will go to the battery and it's 3 kVA. You say 3,000 over 48.
I'm calculating if it is 4 batteries now.
Yes.
Calculating in series now.
Yes.
So that is 48 volts now.
Yes.
Okay.
So it will be 48. That maybe if it's 2,500 watts, it will be 2,500 over 48. That will give you the amps for the DC, the direct current side. Now for the AC, it will be that same 2,500 divided by 220 volts.
That each battery is right.
No battery now, na inverter. Now why are you mixing it up? VDC is dealing with battery, or VAC is dealing with the inverter. If I'm cutting. Are you getting what I'm saying now? VDC is dealing with the battery. This. VAC is dealing with normal electrical cable now. Don't worry, use it the way you use it. There's one thing about battery. You just when you just burn one inverter, naturally you get the answer. VAC is wire from NEPA to your inverter. VDC is connection between your inverter and the battery. And VDC deals with either your jumper cable. If it's DC cable, it is within your panel and your charge controller, or your charge controller and the battery. I think you have followed us for installation. Don't worry, do it the way you want to do it. Yeah. Yeah. Yeah.
Based on the amount of current you are supplying.
Yes. So you divide that inverter, the capacity on that inverter by 220.
Get the
amount of current. So that amount of current, you now put it on your cable gauge. You now use it to know the thickness of the wire on the VAC side.
The 220 is constant.
You know, the 220 is not constant, so that's the standard. In Nigeria, you might have less than 220. If you have multimeter, go and read the electricity in your house. If your house is as close as possible to the transformer, you can even have up to 245. But if it's getting more distance, that's why sometimes you go and buy stabilizer, because you don't have 220. You want to stabilize it from, maybe you want to increase it maybe from 170. You know, you have digital stabilizer that will tell you the current that is coming in and the one that is going out. So I'm saying this one on the perfect level, but on the reality level, when you get to site, you need to know the voltage that is running on that side. If the voltage that is running on that side that you used to divide the capacity of the inverter. So let me say it's 180 volts now. That's coming from NEPA there. You say 2.5 kVA divided by 180. It will give you the amps that will flow. Is that amps that you carry to the chart and go and check it on the cable gauge?
It's better to use standard because they might now introduce the transformers.
Yes, at any time.
Now they have it.
Yes, oh yeah, your current.
So what we were talking about now is on VAC.
VAC.
So now talking about all this master
Okay,
cable
and this one.
and the one that if you want to determine the master cable that we are using now.
That is VDC.
VDC. Would that be the total the active energy or the active this thing?
Yes, now you now be the wattage over VDC.
Total VDC
yes, you know your VDC might either be 12, 24, 36, 48, 96 or 120 depending. So it's not that 120.
I used to divide
the capacity. So you now see the current. That's why in VDC the current is normally higher than VAC. Hope everybody gets it right now. Don't go and use the VAC calculation and say it's 6 mm. Now put that 6 mm to join your inverter to your battery. Don't worry. When the thing gets burned, it will not happen again. It's just once.
Because in a normal
which one is abnormal?
In normal AC.
Yeah.
We think it like lighting.
Yeah.
Those light normal household. We use 1.5 or 1 mm.
Yes.
Then from socket,
yeah, it's
normal socket that can carry iron.
Yeah. It's 2.5.
2.5.
Then AC is 4 mm. It should be 4 mm.
AC is 4 mm.
We still used to those are the only AC that consume a
lot of energy.
So these days that they have reduced their power, we still use 2.5 mm. But if it is story building,
Yes.
Other than you 4
4 mm on it. Hope you get it. It's because it's an electrician, so it's explain deeper. AC size. Okay.
on the
Those batteries are far distance. They will just be. You can even use. It has its own calculation, but you can use lesser size of cable. So instead of using 25, you can use 10 mm cable to loop those where we have small loop together. You don't need special calculation and that is the one that is carrying the bigger current that you must be sure of the standard. Any other question again? So that this class getting too cool, so I'll stop the class here. So I will now give you guys assignments. Assignment number 1 now. It's like you don't like assignment, you know, the first person that gave assignments was an Italian man and he gave it as a result of punishment. He wants to punish those students. Number 1, you write the cable gauge on VAC and VDC for a 20 kVA 120 VDC. That is 20 kVA 120. That is 20 kVA 120 VDC inverter.
So I want to use the.
I will not be the one to give you the solution. You want me to be answering the assignment as I gave you the question.
But we should know the active energy to use it.
Use 20 kVA. Let's assume that the power factor is 0.9. You want it to be more comfortable. The power factor of that 20 kVA inverter is 0.9.
you don't want me to give you. Why you?
Question number 2. I want to give you a normal common houses system 24 VDC 3.5 the cable gauge for both the AC VAC and VDC for 3.5 kVA 24 VDC inverter system and the power factor is 0.8. 3.5 kVA 24 VDC and the power factor is 0.8. I will give you a cheat. The charging that will come in will be based on 20 kVA to charge the inverter. But the energy that the inverter will supply out will be based on kW, kilowatts. Let me leave it that way. Third question. In some high power houses, this one is some high power houses. You have 7.5 kVA, 48 VDC. Calculate the 7.5 kVA inverter, 48 VDC. Calculate the VAC for charging the inverter.
Calculate
The cable gauge for the VAC for charging the inverter. The cable gauge for discharging the inverter or supplying energy to the house. And VDC to connect the inverter to the battery. I should repeat myself again.
calculate the cable gauge for charging.
For charging, the VAC cable gauge for charging your inverter. Number 3B, the VAC for discharging your inverter, I mean supplying load to the building. And the last cable gauge, which is C, the VDC for charging the battery. So for those that have not subscribed to my YouTube channel, you can subscribe. You can comment, you can like. Your question. If the question will have solved the problem in front, I will not answer it. Okay.
Let's say you are using 1.5 kV.
0,
I don't understand.
1.5 kV. Yes, sir.
Right.
I've said it in the class. I will not even answer that question.
How are we going to get
I will not answer that question. I will not answer it because I've already answered it. Go and watch the video again. I've answered that question before. Yeah. So thank you very much.
Once you've been doing before that, having 2 points